today we're going to take a look at day 5. So let's bring up your packet and flip to day 5. So today we're going to look at defining arithmetic and geometric sequences recursively using function notation. So if you remember, arithmetic was when we were adding or subtracting to get the next term, and geometric was when we were multiplying. So first of all, take a look at this and figure out how would you describe to get the next step. And there's lots of different ways you can do that. So once you've figured out how to describe the next step, let's look at this next part. The number of dots, where the dots is a function of the number of steps. So has to do with this. So when there's step 1, there's 1 dot. Step 2, D1 plus 2 equals 3. Day 2 plus 3 equals 6. So how would you describe that they're getting this? So what would this one be? This would be, well, D3 plus 4 equals 10. So our fourth step, 4, it's that step before plus 4. So following the pattern in the table, write an equation for D sub n in terms of the previous step. So the way we do this is, if we want the 5th step, you'll notice we're adding that number, but we want the previous. So the way we write previous is D sub n minus 1 plus that number. So we take how many were in the previous plus that step that we're on. So what would you say? Is this arithmetic, geometric, or neither? So let's see. If I go back up here, we have 1, 3, 6, 10. So I would say this one would be neither, because we're not adding the same or multiplying. So is there a way to express the number of dots in step n without using the value of d? So let's see. If we were to list this number, so we have the sequence 1, 3, 6, 10. Our next one would be 15. So let's see, we're going up by 2, we're going up by 3, we're going up by 4, we're going up by 5. And that I don't know. Is there a way that you can write it without referencing the previous step? You could say we're increasing by 1 more. So that's a good one to ponder. See if you can come up with an expression there. So now we're going to practice writing these recursively and decide if they're arithmetic or geometric. So 30, 40, 50, 60, 70. So that one is, we're adding, so that one's going to be arithmetic. And so the way we write a geometric sequence is we start with our first term. So our first term is 30, because it's like saying if we had our terms here. And then to get any term, we take the previous term and we add 10 to it. So this next one we're cutting in half, so it's geometric. And how do we do this? So we write our first term as 80, and then to get any term, we take half of our previous term. So 1, 2, 4, 8, 16, we're doubling, so that one's geometric. So again, we write that our first term is 1, and to get any term, we double our previous term. Half a fourth is 16, so that again is cutting in half, so it's geometric. So we say our first term is 1. To get any term, it's half our previous term. Let's see, 20, 13, 6, negative 1, 8, so we're going down by 7. So that makes it arithmetic. So we say our first term is 20. To get to any term, we take our previous term and we subtract 7. And this one, let's see, that one's going to be neither. So let's see. So what are we doing on this one? How can we rewrite this one? Let's see, plus 2 plus 4 plus 8 plus 16. So I'm going to write this in a table and see if I can come up with something here. So 1, 2, 3, 4, 5. And our terms go 1, 3, 7, 15, 31. So we keep adding that amount. 2, 4, 8, 16. So one thing I know, these are 1 less than a power, so I'm going to say that, let's see, without a recursive one, I could see it. I would say d sub n equals 2 to the n minus 1, because they're all 1 less than a power of 2. So recursive. I'm going to have to think about the recursive one on that one. So a sequence, again, what we talked about, is a list of numbers. Geometric is when we multiply to get the next term. Arithmetic is when we add or subtract to get the next term. And then recursive is when we are referencing the previous term, and we always start with d sub